Hello everyone, welcome to Gamma Classroom. Today I'm going to introduce divide circuits. The divide circuits include voltage divide circuit and current divide circuit. In this video, we will introduce 1.5-1 voltage divide circuits. Let's analyze a simple series circuit. Determine the voltage drops across individual resistors. In this circuit, the battery is 45 watt. The R1 is 5 kilo ohm, R2 is 10 kilo ohm, R3 is 7.5 kilo ohm. They are series connection. Let's do the calculation on a table. We already learned this before in previous videos. So if you don't know, please check Gamma Classroom the videos. So since this is a series circuit, so the total resistor should equal to the sum of the resistors in this circuit. So RT is total resistor equal to R1 plus R2 plus R3. So it means equal to 5K plus 10K plus 7.5K equal to 22.5 kilo ohm. So we can get this number. In this current, according to the Ohm's law, we already know the voltage. We already know the resistor, total resistor. Then we can do the calculation. Since the current is equal to voltage divided by the resistor. So we already know 45 is the battery voltage. The total resistor is 22.5 kilo ohm. We can get 2 milliamp in this current. Now we get the total current is 2 milliamp. Since in a series circuit, we already learned in any point the current is equal, is the same. So the total current is 2 milliamp. That means the current pass R1, the 5 kilo ohm is the same, should be 2 milliamp. And the same, the current pass through the R2, 10 kilo ohm is the same, is 2 milliamp. The same, the current pass the R3 should be equal to 2 milliamp. Let's take a look on this current, R1. We already know the values of current and the resistors. So according to the Ohm's law, we can get the voltage drop on resistor R1. So E equal to I times R. The current is 2 milliamp and the resistance is 5 kilo ohm. So milliamp with the kilo ohms, we can ignore both. So the voltage equal to 2 times 5, it means it's 10 watt on R1. Similar, we can get the R2 is 2 times 10, it means it's 20 watt. And the R3, we can equal to 2 times 7.5, so equal to 15 watt. We finish all the calculation on this table. Let's review some important points on series circuits. The first one is components in a series circuit share the same current. It means I total equal to I1 equal to I2 equal to IN if there are n resistors in this circuit. So in this circuit, we have 3 resistors. So the current the same. The second, total resistance in a series circuit is equal to the sum of the individual resistors. It means R total equal to R1 plus R2 plus Rn. There are 3 resistors in this circuit, so the total resistor is equal to 5 plus 10 plus 7.5 kilo ohm equal to 22.5 kilo. The number 3, total voltage in a series circuit is equal to the sum of the individual voltage droppers. It means E total equal to E1 plus E2 plus En. Here, the total voltage is 45, and R1 voltage drop is 10, R2 voltage drop is 20, R3 the voltage drop is 15. So 10 plus 20 equal to 30 plus 15 equal to 45. So this table, the calculation is correct. It should be apparent that the voltage drop across each resistor is proportional to its resistance. Given that the current is the same through all resistors, notice how the voltage across R2 is double that of the voltage across R1, just as the resistance of R2 is double that of R1. If we were to change the total voltage, we would find this proportionality of voltage drops remains constant. If we change the total voltage from 45 to 180, so let's do the calculation. So in this current, we know the resistor and the voltage. Then we do the calculation, we can get 8 milliamp. And since in the series circuit, every way the current is the same, so R1 is equal to 8M2, and R2 is equal to 8M, R3 the same, 8M. We can use the same way to do the voltage drop, since the current have been changed. So in this current, we can get 40 watt. 5 times 8 is 40 watt, and this is 80, and this is 60 watt. So total 40 plus 60 equal to 100, plus 80 is 180, is equal to 180 here. And the voltage across R1 is still exactly twice that of R1 drops. You see, 80 is twice of 40. And despite the fact that the source voltage has changed, the proportionality of voltage drops, this means ratio of one to another, is strictly a function of resistance values. Why the voltage drop 80 is twice of R140? Because the R2 resistor is twice the R1. It's 10 kilowatt equal to 2 times 5 kilo ohm. So the voltage is dropped This is choice 2. The voltage drop across each resistor is a fixed proportion of the supply voltage. The voltage across R1, for example, was 10 volts when the battery supply was 45 volts. When the battery voltage was increased to 180 volts, 4 times as much, the voltage drop across R1 also increased by a factor of 4, from 10 to 40 volts. The ratio between R1's voltage drop and the total voltage, however, did not change. The ratio between R1 voltage drops and total voltage, however, did not change. Let's look at this. This is the voltage drop across R1. This is the total watt, the power source. So equal R1 before is the 10 watt and the voltage battery is 45. This number is equal to, even the battery voltage increased to 180, and R1, the voltage drop across R1, increased to 42. So the ratio is exactly the same, equal to 0.22222. You can do the calculation by yourself. Likewise, none of the other voltage drop ratios changed with the increased supply voltage either. So in the R2, the voltage drop across R2 is the same to the total voltage is 20 divided by 45 is the same, equal to 80 divided by 80, 180 is equal to 0.444. Yeah. And the R3, the voltage drop across R3 is the same. The first one is 15 divided by 45. After the battery voltage increase is equal to 60 divided by 180 is equal to 0.333. For this reason, a series circuit is often called a voltage divider for its ability to proportion or divide the total voltage into fractional portions of a constant ratio. With a little bit of algebra, we can derive a formula for determining series resistor voltage drop, giving nothing more than total voltage, individual resistance, and total resistance. Voltage drop across any resistance, according to Ohm's law, EM equal to IM times Rm. And current in a series circuit is I total equal to E total divided by R total. Since the current in a series circuit is the same in any point, so we can use substituting E total divided by R total. It means this one for Im in the equation to the equation 1 here. So we can write the formula. So the EM, this one, EM equal to IN. IN is equal to this part. This means E total divided by R total. So E total divided by R total and times Rn. Rm this way. So we change a little bit. We move the E total, the voltage, out of the here and change the Rm, move to this side. So the formula we call equal to EM equal E total. M means the voltage drop on Rn, means Rm divided by R total. The ratio of individual resistance to total resistance is the same as the ratio of individual voltage drop to total supply voltage in a voltage divider circuit. This is known as the voltage divider formula, and it is a shortcut method for determining voltage drop in a series circuit without going through the current calculations of ohms law. Using this formula, we can re-analyze the example circuit's voltage drop in few steps. So this we already do the calculation for this circuit. The voltage, the total power supply is 45. So the voltage drop across R1, we don't want to do all the complete calculation. We just use this simple formula here. So the voltage drop across R1 is equal to the total voltage 45, and use the 5 kilo ohm is R1, this is 5 kilo ohm, divided by the total resistance in this circuit. This is 22.5 kilo ohm. We can get 10 watt. Similarly, we get the voltage drop across R2, R3. Use the same formula, we get to 20 watt and 15 watt. Voltage dividers find wide application in electronic meter circuits, where specific combinations of series resistors are used to divide a voltage into precise proportions as part of a voltage measurement devices. Let's take a look at this divide. This input voltage, we can consider this as the power supply or the total voltage, and then this we can think is a series circuit. If you want to get portion of the total voltage, you just need to do the calculation what the resistor R1 with the total resistor, the ratio. We only need the ratio R2 divided by R1 plus R2. So then we can get the divided voltage. This we call the voltage divide. We can get any value. We can change the value R2 to different value and get different voltage, the divided voltage. One device frequently used as a voltage dividing component is the Partition Meter, which is a resistor with a movable element positioned by a manual knob or lever. The movable element, this point, typically called a wiper, is a wiper conductor. They can move up and move down. When move up or move down, this point, between this point and this point, the voltage will be changed. Let's take a look at the Partition Meter. This is a vertical resistor strip. So point 1 and point 2 connect to a battery. This voltage, total voltage, is constant, no change. And this arrow face to the resistor. This we call the wiper contact. They can move up and move down. And when the wiper move up, and the resistor between this point with point 1 is less, is smaller, and the resistor between this point with terminal 2 is bigger. So if the resistor is bigger and the voltage drop between this point and this point is bigger, and the voltage drop between this point with this point is smaller, because this voltage is proportional with this resistors. Similar, if you move the wiper or contact down, going down, and this resistor, this point between the terminal 2 is going smaller or less resistance, and this point between terminal 1 is going to bigger or more resistance. So this voltage in this point will going up, and voltage drop between the 2 points will going to smaller. So this is the divide. You can adjust the wiper and get any voltage you want between the 2 points. This one with this one, or this one with this one. Let's take a look at the rotary potentiometer construction. You see, this is a resistor. We call the resistive strip. You see, from this point to this point, we call point 1, point 2, or point 3 here. And in the middle, they have the wiper. The wiper can move this way or move to this way. Both. So like this one. So this is 1 point, terminal 1, terminal 2, and this terminal 3. Then terminal 3 is connected to the wiper, and the wiper can move this way, like to here, or move this way to here. So when the wiper is moved to this way, and this part of the resistor is smaller, going to smaller, and this part of the resistor is going bigger. So when connect the point this one and the point this 2 points, the voltage will increase. Means when the wiper goes this side, this 2 point voltage will increase, and this 2 point then will go to smaller. It's proportional with the resistor. This is the total resistor. This we call the point 1 with the wiper. We call the R1, similar like the R1. And the wiper, between wiper and the terminal 2, we call the R2. So this portion resistor will be going up. Reverse, the same. If you're the wiper going this way, move to this port, then this voltage drop between these 2 points will go to smaller, and this voltage between these 2 points will go into bigger. This is a linear potentiometer construction. This is the resistor strip, the resistive strip. This is the terminal. We call this 1, 2, 3. We'll call 1, 2, 3, doesn't matter. And this wiper can move from go to the left or go to right. If this wiper going to left, so the voltage between this point and this point will go to smaller, and the reverse, this point between this point with this point will go into bigger. The same with the rotary resistor, the partition meter. If we draw a diagram and using a potential meter as a variable voltage divider. So this is a battery. This is the total voltage between these 2 points, this one and this one. If you want to get a portion of the total voltage, you just and move the wiper down or up and reach your voltage in this 2 points. So if you go up, you get the high voltage. If you going down, and get less voltage. This is a complete schematic diagram for Partition Meter. So this is a battery. We can get different voltage level, use different battery. This is adjust Partition Meter to obtain desired voltage. So you can move the wiper up and down. And look at this bit. You move this wiper to reach you want the voltage level. Then you can stop this point. Then can get the voltage from the battery which you want. This is the all that we should learn in this video. Let's review the main point. Number 1. Series circuits proportion or divide the total supply voltage among individual voltage drops. The proportions being strictly dependent upon resistance. E Rm equal to E total times Rm divided by R total. The number 2, a potential meter is a variable resistance component with 3 connection points, frequently used as an adjustable voltage divider. Thank you for watching. See you next video. The next video will be the divide circuits 2, current divide circuits. Thank you.